Hello everyone! This video will be discussing your rapid sand filter design project produced by East Central University and the University of Oklahoma. To introduce what a rapid sand filter is, a rapid sand filter uses different types of coarse sand to remove fine suspended solids from the water. In this image here is a rapid sand filter column filled with various types of sand media. Each media type has a different purpose for filtering water. For our top layer, we have coal, which helps with removing suspended solids and backwashing or cleaning your system. This is followed by a large volume of sand, which can remove fine particles suspended in solution, followed by a support layer of small gravel and large rock, which helps remove larger particles. And so in water treatment systems, they will have large basins filled with different size media, similar to the column shown here to our left. Using a rapid sand filter on a large scale can help remove suspended solids in larger quantities of water so that the receiving cities and towns have clean drinking water. And so many of you who are on city water or receive water through a distribution system have been using water that has been treated through sand filters. And so sand filters have been found to be the most cost-effective way on treating large amounts of water for communities to use. And so for your design project overview, your design objective will be using the material supplied, design, construct, and test a rapid sand filter to treat 1 liter of raw source water to a final turbidity of less than 1 NTU. And an NTU is the unit of measurement for turbidity, and turbidity measures the clarity of water. And so you all will be using an instrument called a turbidimeter that looks just like this. And so here is the power button, and here is your read button. And so when you place your sample inside the turbidimeter and press read, it will give you the turbidity, which is the clarity of your sample of water. But how does this work? By the power of light. As your sample is being read inside the turbidimeter, the light is shined onto the sample. The light will then reflect off of the particles, and the detector will read the scattered light to determine your turbidity. And so for your design criteria, you all will have to treat a total volume of 1 liter. And the total time to treat or filter through your designed filter should be less than 45 minutes. A maximum final effluent quality should be achieved of less than 1 NTU. And your total maximum cost should be less than or equal to $15,230. Lastly, your design constraints are that the maximum filter media volume is 50 milliliters. And your filter size is limited to an 8-inch long, 1-inch overall diameter column, and you can only use the materials that are supplied to you. And so here are the different medias that are going to be available to you all. We have a 40 by 50 sand, 60 by 80, 80 by 120 rock, and then a 1/4 by 1/8 larger rock, followed with your required granulated activated carbon or charcoal right here. And so we're going to start with our 40 by 50 sand. So here we are looking at our 40 by 50 media, our sand media. You notice how it is very tiny and small compared to our 1/4 by 1/8 large rock. So your 40 by 50 sand media will help you remove those smaller particles that are in solution, which overall will help your turbidity or the clarity of your final sample water that has been filtered through. However, sand is more likely to become more clogged as it's filtered through. And so this will increase your filter runtime, which will overall increase the cost. So choose wisely on your media. So here we have both our 60 by 80 and 80 by 120 rock medias. And so looking at these two, you can kind of see that they're relatively similar in size. However, the 80 by 120 is slightly larger than the 60 by 80. But both medias will help filter out large and medium-sized particles in your initial dirty sample water. And so something similar to your 40 by 50 sand is that these will also help reduce your final turbidity relatively low. And the cool thing about these two is that they also reduce your run filter time very much from your sand. So it's important that we use these for sure. And so you may be wondering, why do these two filter out faster than you would the sand? And so these two filter out a little bit faster because these particles are a little bit bigger. And so the pore space for the water to trickle through or filter through is much larger than the sand. It's very tight. And so if I were to pour water through this, it'd take a while. But if I have a little hole, your water can filter much faster. And so that's why these two are able to filter the water faster. And so here we have our 1/4 by 1/8 rock media, which will be our largest media available to you all. It is important to use this media size because it will help filter out your larger particles in solution. Yes, they will. However, it will not help filter out your smaller and medium-sized particles. So the pore space that I mentioned before is getting larger the bigger the media size we go. And so if we have a bigger pore space, it can allow for smaller particles to filter through, unfortunately. And so this will negatively affect your turbidity. However, it does provide you with the fastest filter runtime. So you may need to choose wisely on how much you use this media. And so moving forward, we have our granulated activated carbon or charcoal. And this is a required media that you have to use. You will be using 5 grams of the activated media on my table here. And so the purpose of GAC, or granulated activated carbon, is to help with taste and odor control. So no, you will not be drinking this water. No, you will not drink this water. However, if you had water, that distilled water, deionized water, purified water, it tastes a little bit different. And so in drinking water treatment, they will always have a layer of granulated activated carbon or charcoal to help with the taste. And so this overall just aesthetically improves the water quality and reduces the amount of complaints that you get from people saying the water tastes disgusting. It is also important to note here that where you put your GAC in your system is important. If you place it at the top, you're not really treating the drinking water taste and odor control. So make sure that you place your GAC lower in your filter system so that way the water is going to be tasting and smelling better. You guys are allowed to smell the water before and after, but you guys are not allowed to drink the water. Not. And so those were just a little bit of useful tips for your filter media that you guys have available to you all. Make sure that during your testing time, your trials, make sure you're looking at the filter runtime, you're looking at the turbidity, so that way you can build the best filter. And so let's take a look at an example of one. So you don't have to go nowhere. I already have one built here. But I want you guys all to notice the variety of medias used in this filter and the amount. And so initially we have our support layer with our large and medium-sized rock, followed with our granulated activated charcoal, which is used for taste and odor control. Yes, I know you guys got that right. Followed with sand, the 40 by 50 media on top, and possibly 60 by 80 or 80 by 120 on top of the sand. And so the most important thing to note here is the order of the media. And so this filter design uses a support layer and goes from smallest to biggest. That is just one of the possible many combinations you guys can all come up with. You can go from smallest to biggest like this. You can go from biggest to smallest. You can go from small, big, small, big, small, big. It is entirely up to you guys. You guys have the freedom to do your filter however you want to do. Just make sure that you design your filter and place them in the right order and use the right amount in order to get the best results.
And so when you guys are all building your filters, there are certain steps that you will need to follow. And the first most important step is loading your filter with water. So we're going to add about 50 milliliters of water into our column. And then we'll add our media in whatever chosen order you guys all will decide. So notice how dirty our water is after we added the media to the filter. And so we have to wash out our system with about 200 milliliters of clean water. And so we've added that to our system, and now we're just going to allow it to filter through until it reaches this line here. And so once you have finished washing your filter, you can now begin to add your dirty sample water. And so here is our dirty water filtering through our filter, and here are the final results.
And so for your filter design project, you have a capital and maintenance and operation cost. For your filter runtime cost, you will be charged for how long it takes for the water to filter through your system. You will also have a capital cost for each media. This means that each media will be charged at a different pricing per gram used in your column. You will also have a build time cost, which starts from your conceptual design down to your final filter designed as built. Next, you will have a turbidity penalty cost. If you do not achieve a turbidity of less than 1 NTU, you will be penalized. And finally, there will be a charge for the filter that was provided to you. in addition to the required 5 grams of granulated activated carbon needed in your system. Lastly, you all will have to provide a final presentation. These will be 3-minute presentations that must include the following. You must discuss your selected media, meaning the mass and grain size used in your column. You will also discuss why you chose your specific media order. You will also provide the total cost or the sum of your capital and operation and maintenance costs. And then you will have to discuss your final effluent turbidity.
So, good luck to you all on making your filters.